Hello everyone. We are going to talk about factoring polynomials today. That is 3.6 in your textbook. So let's look at remainder theorem first. When f of x is divided by x minus a, the remainder is equal to f of a. If the remainder is 0, then x minus a is a factor of f of x. So this is what it means. Let's say the question is telling you that x minus 5, you want to find the remainder of f of x when it is divided by x minus 5. You are going to substitute 5 in the function to find the remainder. So you don't have to do the long division or the synthetic division. If you want to find the remainder, you can just use this remainder theorem to do that. Okay, and if you get the remainder being 0, then x minus a is a factor. In this case, let's say you are dividing f of x by x minus 5, and then you substitute 5 in the f function. Then if you get 0 as a remainder, then you can say that x minus 5 is a factor of f of x. Let's look at example 1. Find the remainder when f of x equals 2x cubed minus 5x plus 7 is divided by x minus 3. Again, you take this, okay? So you make it equal to 0. Then you solve for x, 3. Then you substitute 3 in f function. So we get 2 times 27 minus 5 times 3 plus 7. And if you calculate this, you get 46. So that is the remainder, okay? When this f of x is divided by x minus 3. So what's the factor theorem then? X minus a is a factor of f of x if and only if f of a equals 0. So again, if the remainder is 0, then x minus a is a factor of f of x. So let's look at example 2. Which of the following factors of p of x equals x cubed plus 2x squared minus 11x minus 12? So we are going to check each of these, okay? So a, x minus 3. Again, you make this equal to 0, solve for x, then you get 3. Then you substitute 3 in not f but p function. So we get 27. So 3 cubed is 27. 2 times 9 is 18. Negative 11 times 3, negative 33 minus 12. So you get 0 from this. Okay. So then we can say that x minus 3 is a factor of p of x. Okay. So the next one is x. When you make it equal to 0, you get x equals 0. Therefore, you are going to substitute 0 in the p equation. If you do that, 0, 0, 0, you get negative 12. So this is not equal to 0. Therefore, x is not a factor of p of x. Okay. Next one is 2x minus 1. So again, if you make this equal to 0, solve for x, you get 1 over 2. So you substitute 1 over 2 in the function. So you get 1 over 2 cubed is 1 over 8 plus 2 times 1 over 2 square is 1 over 4 minus 11 over 2 minus 12. So even without calculating, you can see that this is not equal to 0. Okay. Therefore, 2x minus 1 is not a factor of p of x. Let's check the next one. We see x plus 1 here. If you make this equal to 0 and solve for x, you get x equals negative 1. Okay, so we are going to substitute negative 1 in the p function. So we get negative 1 plus 2 times negative 1 square is 2. Negative 11 times negative 1 plus 11 minus 12. So we get from here 0. Therefore, x plus 1 is a factor of P of X. Let's look at example 3. Given the following functions, find x-intercepts. So to be able to find x-intercepts, we need to factor this polynomial. This is how we do it. Okay. First, if there's any common factor, you should factor that out. After that, you look at the constant at the end and find the factors of that number. So 16, okay, so we have plus and minus 1, plus and minus 2 are factors, plus and minus 4. So 16 is not divisible by 3. So, but 4, you can divide 16 by 4. And then we have plus and minus 8, plus and minus 16. Okay. What are we trying to do is, we want to substitute those numbers in the P function to get a 0. Because if we see that if one of those numbers gives us 0 as a remainder, then we can say that that is a factor of that polynomial. After we find the first factor, so this is a cubic function, okay? So we can divide this polynomial by that first factor, and then we will get a trinomial. Then you can factor that as well, and then you can fully factor P of X by doing that, okay? So now let's try. Maybe I will do it on a separate piece of paper here, okay? So we are substituting 1. So what do we get? 1 minus 8 plus 20 minus 16. The easiest way is collecting positive numbers and negative numbers to see if we are getting 0. In this case, we get positive 21 minus 24. So this is not equal to 0. Okay. Then we are going to try negative 1. We always start from the smaller numbers and go up. So, and of course, we want to, hopefully, we are going to get a factor before we reach 16, right? Otherwise, it would take so much time. Yeah, let's try negative 1, right? We substitute negative 1. We get negative 1, negative 8, negative 20, negative 16. So all the numbers are negative. There is no way that this is going to be a 0. So we move on. Substitute 2. 8 minus 32 plus 40 minus 16. So if you look at this, positive numbers are 48. Negative numbers gives you 48 as well. So this is equal to 0. So then we found what gives us a remainder 0, right? That is 2. So this is telling you that x minus 2 is a factor of P of x. Okay. After we find that, so now we can divide this polynomial by x minus 2 to get the trinomial. Okay. Okay, let's do that. So you can use here either long division or a synthetic division, but since this is linear, we can just use synthetic division. That should take less time. Okay. So again, to use the synthetic division, we check if the polynomial is in descending order. Then we also check if there's any missing terms, so we can fill it with 0. In this case, x cubed, x squared, x, and a constant. So looks like everything is fine. So we are just going to take the coefficients 1, negative 8, 20, negative 16. On the left side, again, we are dividing it by x minus 2. So you make it equal to 0. So for x, that gives you 2. So we put the 2 on the left. Okay. So you pull this down as it is. 1. 1 times 2. 2. Add them up. Negative 6. Negative 6 times 2. Negative 12. Add them up. 8. 8 times 2. 16. This one gives you 0. We expected to get remainder 0 because we just tried it anyway, right? We tried 2 in the polynomial function. We got remainder being 0. Therefore, of course, you're going to get 0 here too as a remainder. So then P of x, we got the first factor, x minus 2. Then this is the quotient from this division. So we are going to use those for the coefficients for the quotient, right? So that gives you, this is for x to the power of 0, this is for x to the power of 1, this is for x to the power of 2. So x squared minus 6x plus 8. Then we can factor this trinomial, x and x. So it looks like it's going to be x minus 2, x minus 4. So we fully factored this P of x now. Okay, but see x minus 2, you have a double root at 2. So we're going to write it as x minus 2 squared times x minus 4. The x-intercepts then 2 and 4. It doesn't tell you to sketch it, but we can do a quick sketch here. We can find also the y-intercept. Okay, so as you see, the y-intercept is negative 16. Then when you're sketching any polynomial, you check the degree. It is 3. It's an odd degree function. Check the leading coefficient, positive. So you know that your graph is going to start from quadrant 3 and end in quadrant 1. Okay. So when you're sketching, make sure you pass through the y-axis. Now when you reach the first x-intercept on the left, you check the order. So that has an order too. Means you are going to make a parabolic behavior around that x-intercept. Okay? And then you go to the next x-intercept, which is 4. That has an order 1. So means that you're going to do a linear behavior around that x-intercept. Means you're just passing through this line. That's how it would look like. Let's look at the next example. So we have this as a P of x. Okay. So again, the first thing that you should do, check for a common factor. So we see that each term has x as a common factor. So we are going to factor that out. Also, if the leading coefficient is negative, you should certainly factor that out as well. So it will make your life easier if you do that. Okay. So then I am factoring negative x here. So that would give me 2x to the power of 4 plus 3x cubed minus 20x squared minus 27x plus 18. Okay. Now we are going to factor this part of the polynomial, right? Then we are going to check the factors of 18. So that is plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, plus and minus 18. Okay. Then we start. Again, I'm going to use another piece of paper here. So I'm going to start trying. Okay. P of 1. So when I'm trying, because I already factored out negative x, I'm just going to look at this part. Okay. After the negative x is factored out. I'm going to substitute 1 here to see if x minus 1 is a factor of this part. All right, substitute 2 plus 3 minus 20 minus 27 plus 18. So this is not equal to 0, as you can see. So now we try negative 1. So we get 2 minus 3 minus 20 plus 27 plus 18. So as you see, this is also not equal to 0. So we move on. We try 2. Okay. So 32, because 2 to the power of 4 is 16. 16 times 2 is 32. 2 cubed is 8. 8 times 3 is 24. Okay. Then 2 square is 4. 4 times 20 is 80. 54 plus 18. So if you check this, again, this is not equal to 0. Okay. So let's try now negative 2. Negative 2 to the power of 4 again is 16. 16 times 2 is 32. Negative 2 cube, negative 8 times 3, negative 24. Negative 2 squared is 4. 4 times negative 20 is negative 80. Negative 2 times negative 27, 54 plus 80. So if you look at this, okay, negative numbers giving you negative 108. Also, if you collect these, also it gives you the same thing. Okay, so positive 108. So this is giving you a 0. So after you find the first 0, right? So it means that x plus 2 is a factor of p of x. So now we are going to divide, not this whole thing, but you know we have this part of the polynomial after we factor out negative x. So we are going to divide this part, okay, by x plus 2. Okay, let's do that. So I'm going to use again the synthetic division. Okay, we said x plus 2. Then if you make it equal to 0, you get negative 2. The negative 2 is here too, right? So we are going to put negative 2 on the left. Then take the coefficient of this. 2, 3, negative 20, negative 27, 18. Okay, so pull the first number down. 2. 2 times negative 4, negative 2, negative 4. We get negative 1 from here. Negative 1 times negative 2 gives you 2, negative 18. Negative 18 times negative 2 gives you 36. So add them up, you get 9. 9 times negative 2 gives you negative 18. When you add them up, you get 0. Okay, then so far that's what we have. Okay, p of x, we had negative x. Now we have x plus 2 as a factor. Now we're going to write the rest of it. Okay, again, so this is the remainder. This is a coefficient for x to the power of 0. This for x to the power of 1, x to the power of 2, x to the power of 3. So 2x cubed minus x squared minus 18x plus 9. Still, we don't have a trinomial yet. Okay, if we had a trinomial, so we could easily factor it like the previous example, but we are not there yet. So now we have to factor this cubic part of this polynomial. Okay, so what are we going to do? Check the factors of, again, this constant. Okay, so plus and minus 1, plus and minus 3, plus and minus 9. Okay, we already tried 1 and negative 1, okay, in the whole function, and we saw that it wasn't equal to 0. So x minus 1 and x plus 1 are not factors of this polynomial. Therefore, there is no need to try again plus and minus 1. So we are going to move on and try 3. Okay, so let's do it again on this paper. So 2 times, I'm trying 3 now. 3 cubed is 27. Okay, minus 3 squared is 9. Minus 18 times, you have 18 times 3 here. Okay, that gives you 54 plus 9. So if you check this, 54 minus 54 is 0. Negative 9, positive 9 is 0. So this is equal to 0. So we just tried 3. So then this is telling you that x minus 3 is a factor. Okay? X minus 3 is a factor. Then now we can divide this polynomial by x minus 3 to factor it further. Okay? So let's do that. So we said x minus 3 is a factor. So now x equals 3 is going to be on the left. And we are going to take the coefficients of this polynomial, 2, negative 1, negative 18, 9. Pull the first number down, 2. 2 times 3, 6. Negative 5, no, positive 5, we are adding. So 15, negative 3, 3 times negative 3 is negative 9, 0. Again, we expected to get 0 for remainder anyway. So we can write this polynomial. I need space. Okay, so I'm going to move here. We can write this polynomial now as negative x, x plus 2, x minus 3, okay? So negative x, x plus 2, the new factor is x minus 3. Now we are going to use these values to write the quotient from this division. So this gives you 2x squared plus 5x minus 3. Okay? So now we are going to factor this trinomial, negative x, x plus 2, x minus 3. Let's factor this. Okay? So we get plus 3 minus 1. Okay? Now this polynomial is fully factored. Okay? What are the x-intercepts? 0, negative 2, positive 3, positive 1 over 2, and negative 3. Even if it doesn't say it, how about if we sketch this function? Okay. Okay, so we have 0, negative 2 and negative 3, negative 2, negative 3, positive 1 over 2, and positive 3. We have 5 x-intercepts. Okay. Then we check the degree of the polynomial. It is 5. So it's an odd degree function. Leading coefficient is negative. So we can again look at this summary, right? So odd degree function with negative leading coefficient is going to go from quadrant 2 to quadrant 4. Okay, quadrant 2 to quadrant 4. Okay, so when we check the factors, they all have exponent of 1. So they're order 1. Therefore, they're going to make linear behavior around, so the graph is going to make linear behavior around those x-intercepts. Okay? So linear behavior, just pass through, pass through, pass through, pass through, and finally pass through. Okay? So that would be the graph of this polynomial. Okay, so let's look at example 4. It says graph the following for x cubed plus 7x squared minus 34x plus 8. So to be able to graph, you need to find, again, so it already says it here, using x and y intercepts. So to get the x-intercepts, again, we need to factor this polynomial. Okay, so same process. If there's any common factor, you check for it. Looks like there is no common factor here. Then we look at the last number, constant. We find the factors of that number. So plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. Okay. Then we start trying here. Okay. So I'm going to substitute 1. 4 plus 7 minus 34 plus 8. This is not equal to 0. So try negative 1. Okay. So we have negative 4 plus 7 plus 34 plus 8. This is also not equal to 0. Now we try 2. 2 gives 8. 8 times 4, 32. 4 times 7, 28 minus 68 plus 8. Okay. So if you look at this, this gives you 60 plus 8, 68. So positive numbers are 68. Negative number is also negative 68. So this is equal to 0. Okay. So this is telling you again, x minus 2 is a factor of this polynomial. Okay. Now we are going to divide this polynomial by x minus 2. Again, I'm going to use synthetic division. 2 on the left, because x minus 2, if you make it equal to 0, you get x equals 2. Okay. Now, let's look at the coefficients of this. 4, 7, negative 34, and 8. First number goes down as it is. 4 times 2, 8. Add them up, 15. 15 times 2 is 30. Add them up, negative 4. 2 times negative 4 is negative 8. We get 0 as a remainder. Okay, P of x. X minus 2 times. Now get this quotient, right? So that gives you 4x squared plus 15x minus 4. Now factor that trinomial further. Okay, so if you do that, you get 4x minus 1, x plus 4. Okay, then the x-intercepts are 2, 1 over 4, and negative 4. What is the y-intercept? 8. Okay, let's sketch. So y-intercept is 8. And intercepts are, x-intercepts are negative 4, 1 over 2, and 2. Check the degree, odd degree. Leading coefficient, positive. So odd degree function with positive leading coefficient goes from quadrant 3 to quadrant 1. Okay. Quadrant 3 to quadrant 1. All right. So check the factors. All of them is order 1. Okay. The exponents of those factors are 1. So means the graph is going to make linear behavior around those x-intercepts. Okay. We pass through the first x-intercept, then the second, and the third. All right. Let's look at example 5. The function p of x is given, but there is one unknown here, k value. Okay, has the same remainder when divided by x minus 1 as divided by x plus 2. Find k value. Okay, now we are going to use remainder theorem to solve this question. If it is telling you if x minus 1 then this polynomial is divided by x minus 1, so remainder, you get a certain remainder. Okay, so when it is divided by x plus 2, you get exactly the same remainder. So let's find that remainder then, right? So p of 1, we're going to find first the remainder when it is divided by x minus 1. So we substitute 1 in this polynomial. So we get 1 plus 6 plus k minus 4. So this gives you 3 plus k. Okay. 3 plus k is the remainder when this polynomial is divided by x minus 1. Let's find the remainder when it is divided by x plus 2. So then I'm going to substitute negative 2 in the p function. Okay. So that gives us negative 8. Negative 2 squared is 4. 4 times 6 is 24. Minus 2k minus 4. Okay, simplify. We get 12 minus 2k. So we have two remainders, but the question is telling you that those two remainders are the same. Okay, so then p of 1 equals p of negative 2. 3 plus k equals 12 minus 2k. Okay, so I'm going to move negative 2k to the other side, 3k. 3 to the right. 12 minus 3 gives you 9. So divide both sides by 3. That gives you k equals 3. Okay. Let's look at example 6. Then 2x minus 3 minus an x squared plus an x minus 2 is divided by x plus 1. The remainder is negative 12. When it is divided by x minus 2, it is x minus 2 is a factor. Okay, so that then remainder is 0. So find m and n. So this time, not only one variable, but there is two unknowns. Not only one unknown, but two unknowns in this polynomial. Okay, in this question. So let's start. It says that when it is divided by x plus 1, the remainder is negative 12. So then, if we substitute negative 1 in this polynomial, so this is the remainder, right? So that is equal to negative 12. Okay, that is the first information. Second information, when this is divided by x minus 2, okay, the remainder is 0 because x minus 2 is a factor. So when we substitute then 2 in this polynomial, because it is a factor, I should be getting 0 as remainder. Okay, so let's substitute negative 1. So negative 1 cubed is negative 1 times 2, negative 2. Okay, negative 1 squared is 1 times negative m, negative m. Negative 1 times n, negative n, minus 2 equals negative 12. Okay, so let's simplify. So we have negative 4, move it to the other side, positive 4. So negative 12 plus 4 gives you negative 8. So you see that all of them are negative. Actually, if we want to get rid of them, okay, so we can multiply every term by negative 1. Or divide every term by negative 1 to get m plus n equals 8. So we got one equation from here. Okay, let's look at the second one. So we substitute 2 now. Okay, so that gives us 2 cubed is 8. 8 times 2 is 16. 2 squared is 4, negative 4m. 2 times n plus 2n minus 2 equals. So negative 4m plus 2n. So 16 minus 2 gives you 14. Move it to the other side, negative 14. Okay. As you see, all the terms can be divided by 2. Whenever you see that you can simplify something, you should attack it right away. So in this case, I want to simplify it. I don't want to deal with the big numbers at the end. So I'm going to divide every term by 2. So negative 2m plus n equals negative 7. So this is your equation number 2. Now you should remember this, how to solve this from grade 10. If you have two equations with two unknown, you can solve it using substitution or elimination method. Okay, so we prefer definitely elimination method. So we have equation 1, m plus n equals 8. equation 2, negative 2m plus n equals negative 7. Okay. When you are doing the elimination, you can add or subtract to eliminate one of the variables. In this case, they have the same coefficient, so you don't have to multiply any equation with any number, because when we subtract second equation from the first one, n will disappear, right? You are going to eliminate n. Let's do that. M minus negative 2m, 3m. N minus n, 0. 8 minus negative 7, 15. Divide both sides by 3, you get m equals 5. Then you take that, sub in equation 1 or 2. Okay, so let's sub in 1. 5 plus n equals 8. So n equals 3. Now we solve. Okay. Example 7. It says factor and find zeros, but this time we are going to use group factoring. These polynomials definitely can be factored by using the factor theorem. Okay. But sometimes group factoring is much shorter. So you can use group factoring if there's 4 terms. Okay, it only works with 4 terms, right? Not always you can use group factoring. Most of the times you will have to use the factor theorem. Okay, but once in a while, if you can see that you can factor it by group factoring, you should try that. Okay, so this is what I'm going to do. So I'm going to take the first 2 terms and put it together. Okay, then I'm going to factor each bracket. So we see that x cubed is a factor for the first one, and we see that 27 is a factor for the second one. Now we see that 3x squared minus 4 is a common factor. Then we get x cubed from the first one and 27 from the second one. Okay. Well, actually with 3.7, you're going to also learn how to factor sum of cubes and difference of cubes. But for now, let it be. And we are going to find now the zeros from here. Okay, so you make this equal to 0. That gives you 3x squared minus 4 is 0. Okay, so we are going to solve that. So 3x squared minus 4 equals 0. That gives you x squared equals 4 over 3. Then you take the square root of both sides. Don't forget to take plus and minus from it. Okay. So x equals plus and minus square root of 4 over 3, which is 2 over root 3. And we always rationalize the denominator. Don't forget that. Okay. So x equals plus and minus 2 root 3 over 3. All right. Now let's get the 0 from the second factor. So you take x cubed plus 27, make it equal to 0. So you get x cubed equals negative 27. Then you take the cube root of both sides. Cube root of negative 27 is negative 3. Then you get x equals negative 3. So you have 3 x-intercepts or zeros. X equals 3. X equals 2 root 3 over 3. X equals negative 2 root 3 over 3. Okay. So let's look at the second one. Again, we're going to do group factoring. By the way, here we took first 2 and last 2 and put them in groups, but it may not always be the case. Sometimes you may need to take first and third term and put it together, or first and fourth term and put it together, and the rest of it in a bracket. Okay. So Again, I'm going to take 36x cubed minus 4x squared and 9x minus 1, put them in groups. Okay. So from the first one, we see that 4x squared is a common factor. So that gives you 9x minus 1. And we already have 9x minus 1 from the second one. So now we see that 9x minus 1 is a common factor. You take the first term divided by 9x minus 1, you get 4x squared. Then you take the second term divided by 9x minus 1, and that gives you 1. Okay, so to solve for zeros, we make this equation equal to 0. Okay, so this gives you x equals 1 over 9. From the second one, what do you get? X equals negative 1 over 4, which is not possible, right? When you square anything, you never get a negative number. So no zeros from here. From the first one, we get x equals 1 over 9. So related homework is here. Okay. And on the next page in your package, question number 1 is for practicing the group factoring. Okay. And ignore 2 and 3 for now.